Drum roll that Festo have laid on for us. Ladies and gentlemen, roll up, roll up. Okay, I hope this is going to be a really well spent 20-minute presentation, and then we're going to have 20 odd minutes for a discussion, questions from the audience. I'm delighted today to bring you Mark Gillingham, who is the president of PolyUnity, Jacqueline Lee, who is the CEO. I may have got that the wrong way around, but they're fantastic people. So Mark and Jacqueline, I leave it to you to get us started on PolyUnity, the art of the possible.
Thank you so much, Mark. Thank you everybody for attending. This is incredible. And I want to thank Engine and Canada Makes for the opportunity to be up here today. We did a project with Engine actually a couple of years ago, a 2-year project that ended in 2023. So lots of exciting stuff coming up in our future. Maybe we can do another one. We're going to talk about 3D printing and its application in healthcare. So the Canadian healthcare system, I'm sure you all are aware of how much trouble we're in and the problems we're experiencing. There's escalating costs, there's worsening outcomes. People are taxed, we're losing our doctors. It's an incredibly challenging situation right now. Supply chain fragility. There's tankers that are not showing up. There's ships being stuck in the Suez Canal. There's increasing supply chain shortages all the time. And we're realizing more and more of our overdependence on U.S. suppliers, especially now with the tariffs facing us. Hospitals are now looking at how completely dependent they are on U.S. vendors and how we need to switch this. And then, of course, adoption is incredibly slow and fragmented for innovation and emerging technologies. And what we're doing at PolyUnity, I hope that we can tackle that. So as awful as all of this is, we find this incredibly exciting. There's opportunity here, and we're ready to tackle it.
Thank you, Jacqueline. So we started off talking about healthcare and additive manufacturing, and you may wonder why you're seeing a picture of the International Space Station here, but PolyUnity's genesis story actually started with 3 medical doctors who founded the company, 2 who are now surgeons. The other person was a family doctor, and we're very proud to announce he recently rejoined us as our chief medical officer. And but there was a period where they had founded a 3D print organization as they were going through their med school. And ultimately one day they were sitting down and there was a situation on the space station. And as is cliche, the astronauts called down and say, "Houston, we have a problem." The issue was they didn't have the part to fix the problem on the space station, but what they did have was a 3D printer. And so engineers on Earth created the part, digitally teleported it to the space station, they printed the part, fixed the issue. And that was a huge aha moment for these 3 individuals. And they thought, wow, if we can teleport parts to space, why can't we get them in the hands of healthcare workers where they're needed, when they're needed, through the same type of distribution network, and manufacture things at or near the point of consumption? So looking at what are the foundational technologies you need to deliver something like that. And one of the amazing things we've seen, 3D printing has been around for about 40 years right now, but it's in the last 5 to 7 years that we're seeing this exponential growth curve in capabilities. And it starts really with the ability to design products, to manufacture them through 3D printing or additive manufacturing. And the ability to do that very, very rapidly in sometimes minutes and hours and days, and it's not weeks and months anymore. The ability to scan with an iPhone or another type of device to go straight to a CAD file that you can then manufacture and print. And obviously all of this is getting really enhanced with the power of AI. Digital inventory is one of my phenomenal, fascinating topics that I just love to chat about. But the concept, I'm sure that we're all familiar with. When an industry gets digitized, it actually gets larger, it gets more efficient. And so this is true in the cases of things like Uber, which is the largest transportation network in the world right now, Airbnb, which is the largest hotel chain, even though they're complete digital platforms. And for any of you who are, I'll date myself, but do you remember when you would order your CDs online and you would get them come in the Columbia House package? We'd get the physical music, and you'd be limited obviously to the ones that you actually selected. Now we're in a world where all of that is in a digital inventory system, and the ability to actually get what you want when you want in real time is ever present. And the same holds true for digital inventory. So we don't necessarily need to move products all over the world right now. The concept of a digital distributed manufacturing network means that we can send that digital inventory file to the place it's needed, manufacture what we need when we need it. The other thing that's really increasing is the advanced materials engineering capabilities around the world. And we're seeing this with, advanced polymers like PEEK and PEC, even just ABS and PLA and standard polymers that we make things out of, and also the metal side of things. And we have our friends from Atlantic XL here today who run a metal 3D printing operation in Atlantic Canada as well. And the ability to then take all of these advanced materials and create products with them that have ever-increasing strength, durability, chemical properties for heat and different types of resistance. And then obviously there's the advanced manufacturing network. And what we're seeing across the whole spectrum is, almost a whole order of magnitude in increase in speed and output of production just over the last few years. So it's a 9 or 10x, ability to output, which means we can make more things faster. Also, the capabilities, the quality of the output is really, really increasing. And we're seeing software automations that, again, just add to this, the ability to network machines. And then, once again, we're seeing AI come over the top of this, especially with regard to quality of output. And there are great companies right now that are working on the concept of born qualified parts, which means that these production machines will have sensors in them that look from cameras and thermal imaging and a whole bunch of sensors. So you can detect if there's a flaw in that production part as it's being manufactured, to be able to tie that directly into your QMS system so you don't have to pick it up at a later part. So now we'll bring it all back to healthcare. All of these great technologies have the ability and are really transforming the way healthcare is being delivered. And we're seeing this in a whole bunch of applications. So this is not PolyUnity's kind of product set here. This is the industry-leading applications of where additive manufacturing or 3D printing are impacting healthcare. And it's everything from medical devices and products, wearables that we're going to show you some of in just a little bit, patient-specific anatomical models for pre-surgical planning. And as we start to get more and more to the right side of the screen here on your side, we're also now in very specialized facilities around the world printing with stem cells and bioinks and things of that nature to build scaffolding structures. And to be clear, this is not what PolyUnity's doing, but these technologies exist in different parts of the world. So we've went on a mission based on, kind of what the three founders had envisioned, to get these technologies in the hands of all healthcare workers and not just have it so that it's only in very specialized centers in certain places. And the goal to do that is impeded in some cases with, some of these problems. There's 3D printers in pretty much every healthcare organization that we've encountered over the last while, but they're siloed inside of a clinical engineering department or inside of a diagnostic imaging department. So the question becomes, how do you kind of unleash that and make those machines connected? We have procurement and integration challenges. Anytime someone wants to bring a new product into a healthcare marketplace, they essentially have to sell it to all the healthcare organizations. Risk and liability that comes along with additive manufacturing, digital inventory. These are all brand new technologies. How do we deal with them from a regulatory and risk perspective? And then, we all know the burden that Jacqueline opened up with, that healthcare is under with regard to limited resources. And so the beauty part is that if we can make these technologies accessible, we can actually help to unburden them, give them more of what they need faster, and help them to be more efficient in what they do. So the platform we developed, i3D.health, is essentially, it lives the PolyUnity name. PolyUnity in very literal terms, is defined as many as working as one, or many working in unity. And that applies to all the frontline healthcare workers having one innovative platform where they can come to get the things they need. But it also applies directly to the 3D printed products and the technologies. We want to create a digital marketplace, and are creating a digital marketplace, where we can bring best-of-breed technologies into one singular platform to allow them to have access to all of, again, for all frontline healthcare workers. So it looks something like this. We have a digital library of 3D printed parts. This is our i3D.health platform, where we host those digital files. It has the ability to place orders. It's, again, enterprise level. It's hosted in GCP, Google Cloud Platform. And with that, we also have a product design service where we have professional designers that can create products. If you have an idea, or sometimes we just get people to tell us about their problems. Not all their problems, but problems that pertain to product development. And then once we've created that product, we put it in digital inventory, then they can order it when they need it, and we handle the manufacturing for them as well. And so we're working towards a fully distributed national network that can support all healthcare within Canada. And we've been challenged, and we'll answer some of these questions, I'm sure, later, as to why would you focus strictly on Canada to begin with. And we think that there's probably some challenges with that, but there's a lot of advantages to us building out this national network in Canada first. And once we do it, we then have the ability to export all of that to other parts of the world. So within the platform, without going too deep, some of you probably who have your risk hats on us goes, well, you just can't take 3D printed products and put them into healthcare. And you're absolutely right, you can't. So we hold an MDEL, Medical Device Establishment License, with Health Canada, but we also have developed what we think are kind of first in industry workflows that allow you to take a product, move it through procurement approval, IPAC, which is infection prevention and control, and other stakeholders that need to sign off on the ability to use that product. So now a frontline healthcare worker can not only request a product, but we can bring it through the healthcare system for them, get it approved, put it in digital inventory, then they can order it when they need it. With that and these approval processes, we have audit trails, so who requested it, when was it approved, what does this look like, so you can come back and check at a later date. And then all the ability to do order approvals, financial billing, and of course the reporting that goes along with that. At the end of the day, this is the vision, and it's a distributed network of advanced manufacturing, additive manufacturing silos. We actually got to visit the Accenture tour just yesterday, and their 2040 report says that essentially this is the future. With all the robotics, with all the AI that we're seeing throughout this show, the ability to actually have very efficient, smaller plants distributed where we can make things at or near the point of consumption is the future. And so the thing that we're trying to do is to connect all of those so that there's an application layer at the end of the day that needs to ride over the top of this, that allows someone, when they click that order button, behind the scenes there has to be enough intelligence to point that order to the nearest production facility to make sure it's done in the most efficient manner.
Okay, story time. I'm going to take you through. We've developed over 500 products now, either ourselves or are offering them. I'm just going to take you through 3 quick examples. What's our first one, Mark? The bolus?
It is?
Yeah, this is we developed this for cancer radiation therapy. Traditionally, they would use a plaster of Paris procedure. They'd have to bring the patient in, probably travel from afar, have a very uncomfortable plaster cast made of their face, and then a mold made of it. Often the tumor size would change or swell, and you'd have to repeat this process. We use an existing CT scan. It's actually more accurate. We don't need to see the patient. We create a 3D printed mold, and then we create the positive wax mold, and it goes right on the person's face and directs the radiation therapy in a very targeted and effective and more accurate way. And we deliver this in 4 to 8 hours, where the other solution was days. The ROI on this, I think, is upwards of $10,000 per procedure. We do this in all of Newfoundland and Labrador right now, and are trialing this in 3 other provinces. The next one.
Oh,
Yeah.
Absolutely. Yeah.
Here you go.
Thank you.
Thanks, Mark. Yeah. All of it, yeah. So a lab manager in New Brunswick had a very inefficient pap smear process, a pap test. And she just explained to us what they do today. They sent us example on top of what they actually do. They use 3 different bottles of 3 different sizes, 3 different heights. They don't all fit into the tray. You can imagine sometimes it gets mixed up or contaminated, or it needs to be resampled, and it's incredibly inefficient. So we developed this 3x8 system. The actual unit is much bigger. It's in the hospital colors. There's some cool labeling on it. But it puts all 3 different size bottles in the one tray and has incredibly impacted their workflow. Upwards of, I think, 35% increased efficiency and throughput. I'm gonna pass that around if you'd like. And our last example. This was not available in Canada when we first met these folks. So we're very delighted to start bringing this. Every osteo surgeon that we're showing this to is hugely excited. But this is a 3D printed cast that could replace traditional plaster or fiberglass casts. So PolyUnity has signed a Canada-wide agreement to start to distribute this. The Active Armor folks actually help us. We scan the image here using an iPhone. We send the file off to them. They give us a printed file, and in 8 hours we have a printed cast. So we're really excited to start offering this throughout Canada. Here's a quick 15-second video of the process. It's very cool. I've been wearing it.
This cast is actually customized to Jacqueline. So the scan that was done, as you can see, it conforms, and it's personalized healthcare in the fact that it's a scan to print application.
Yeah, so you can shower with it. It doesn't smell. You can clean it effectively, and the surgeon or your doctor can easily see and assess and track your treatment and improvement.
Yeah, there's many cases where if you had a surgery, your scar is underneath the plaster cast. It can get infected. You can't really see it. You know, it's susceptible to bacterial infection, and this is just for kids, right? Like you can get them back into sports faster. There's all kinds of amazing applications with this, so it's exciting.
So now more than ever, I think Canada needs access to innovation and emerging technologies. I think healthcare is now ready, PolyUnity is ready, and this is Canada's chance to lead. So we'd love to be part of that. Thank you.
Yeah.
Are we sitting down with Mark?
We can sit, we can stand.
Yeah, no, please take a seat. Yeah, brilliant work. I'm going to sit on the end so we don't get any feedback from the. Or maybe I can sit here. Okay. Really inspiring, and I'm reminded of a saying that it's I'm not sure it's Shakespeare or whoever. Nail, shoe, horse, kingdom. For the want of a nail, the shoe was lost, the horse was lost, the kingdom was lost. And it seems to me that it would be a mistake to not understand that an entire hospital can sometimes grind to a halt for the want of something that appears quite simple. You know, all of the things we've looked at today are polymer examples. But I remember you talking about how an air ambulance may not be able to fly because a particular clip isn't present on a stretcher or something like that. So this is ultimately a value-driven proposition, isn't it, Mark?
100%. That application actually, so one of our clients is the Children's Hospital of Eastern Ontario in Ottawa, and ultimately they had a situation where they had 5 of their 6 air ambulance stretchers that were down because they couldn't pass inspection, and they were missing 3 polymer parts. And it was at a point where that CHEO hospital serves the whole Champlain catch basin in southern Ontario, and you know, losing air ambulance service for that region is life or death when you have to start to move people through road ambulance. And anyway, it got to a point where it hit the CEO. He came to us. We actually have a print production center directly in the CHEO hospital, and ultimately, in very quick terms, the clinical engineering team came to us. We created the parts, did it within 24 hours, had to send them out, get them third-party inspected and engineered, certified, brought them back in. put all of the air ambulance stretchers back into operation inside of a few days. And I guess the great point is that they haven't failed inspection since. So, that's one of those situations where you think, oh, okay, it's just a polymer 3D printed part, but when it comes to a hospital operation, with supply chain, they couldn't get the ambulances or the stretchers when they need them. It was going to take kind of too long.
So, following on from that, I'm going to quiz Jacqueline now. You said, I think, that you could maybe take 90% of the cost out of procurement, and goodness knows how much we do spend on procurement. But do you have any idea of how much money you think PolyUnity has saved, really, the Canadian taxpayer so far? Because I think you've got an inventory of 500 parts over a couple of years, but where are you now, and where do you think you might go to if we can build this national network in terms of, how big could this be in terms of the value proposition?
Yeah, I mean, what we sell is access and the platform. So we don't sell widgets exactly. We sell access. So I think we're going to continue to do all kinds of things that we specialize in, but we're going to go out and find those emerging technologies and those solutions that hospitals need and give it to them in a direct access way through our platform, so they don't have to individually procure solutions one by one. I think we've saved our hospitals that we're contracted with millions of dollars. We engaged a healthcare economist when we did our project in the Children's Hospital of Eastern Ontario. And through his 8-month analysis, he determined that we had a 28-to-1 ROI on average of the products that we did develop with them. And that's incredible. 28-to-1 is massive. And he looks at all kinds of things like cost efficiencies, workflow improvements, safety improvements, and environmental impacts. I think you could read any strategic plan from a hospital and you'll find innovation as a leading thing, and value-based healthcare. They all want to procure through value-based mechanisms, but not have a great idea of how to do it. So the more health economics we can use with our solution, with healthcare innovations, I think we'll be better off.
Just on the environmental side of things, if healthcare was a country, it would be the 5th largest contributor of CO2 in the world, a little over 2 gigatons per year. 70%, so 70% of that footprint is all supply chain logistics. It's actually the movement of goods around the world. So when you're sending things, again, you're sending ones and zeros between places. Yes, you have to get the raw materials there, but you can do that in bulk and pretty efficiently. Then you can kind of make the things that you need. And understanding what we're talking about here is not a panacea for all things, but there is certainly a fairly significant amount of product that healthcare, and this applies to probably all industries, that can be developed, manufactured, delivered in a more efficient way through this type of a network.
So we could save emissions because we've got distributed, localized manufacturing. I was intrigued whether healthcare will grow. You gave the examples of Uber and Apple Music and industries that have been digitized that have become bigger. And I think that's a bit of a thought starter as to why that should be. Will healthcare go the same way? How could healthcare be any bigger when we go digital?
It's not necessarily, well, bigger, but just think about it. There's lots of applications where a small, medium, and large is not the right solution. And so one of the things that this type of ability to create variations in product, so, Jacqueline's example of the lab rack, a standard lab rack just does not work here. So where it gets bigger is that there's more variety, more options, more customizations that are just as efficient to deliver and produce, and ultimately it's safer, it's more effective, and better work outcomes at the end of the day.
So it's maybe more customized.
Sure.
Yeah. Okay. Awesome. And you talked about what we need is we have these silos right now. We need some connective tissue. Yesterday we were talking with Otto Motors, who are right behind us with their robots, and they were providing the attraction to Rockwell was they were great at making machines, but the machines weren't actually connected to one another. So Otto provided literally the connective tissue there. But i3D is really the connective tissue. It's the software application that you've spent a long time developing. Can you talk a little bit more about kind of the innovation that you've had there? And you said if somebody has an idea, how are people contributing to that digital inventory, or somebody puts in a need? How do they do that?
Yeah, so, one of the thesis statements I guess we had at the beginning of this, and, all 500 products, I don't know if any of those belong to PolyUnity. We've helped to create them, but the thesis from the beginning was that frontline healthcare workers hold the knowledge about the problems they experience on a daily basis, and in many cases they have lots of great ideas about how to fix them. Again, the gap becomes the situation where they just don't have the tools, or they don't have the time to actually go out and create those products. And so with all the advanced technologies that we kind of covered in the beginning, now you can do this more efficient than ever in the history of humanity. And so the ability to go create a new product to fix that problem and make it more efficient is, it's cost effective, and it makes economic sense at this point. So what we did is we opened up an ideas portal on our platform and just got Frontline, as I joked earlier, to tell us about their problems. And, this is where the first 500 products that we've created in our platform came from. And now that we've got the platform established and kind of the network and the infrastructure, now it's to the things that Jacqueline talked about bringing in. There's lots of brilliant people around the world, in Israel and, the US and wherever, that are creating products and innovations that we could use in Canada. The challenge becomes is that if every healthcare organization has to go out and purchase all 150 of these, or however many hundreds of these products and applications, it's going to take us decades. Canadian healthcare is going to suffer. Our people aren't going to get the potential coverage and the treatment that they could need. And so with a platform that can consolidate PolyUnity, again, it's many as one, bring that together, and then manufacture it inside of Canada. Listen, I'm a part of the CME as well, and a very proud member. Every sustainable society ever on planet Earth has a manufacturing component to its, as part of its sustainability. And I think there's an opportunity here, in Jacqueline's closing slide, for us to reshore and do a lot more of this in a very commonsensical, economical way back in Canada.
And we're here at Hanover Messe. Obviously, we're just surrounded by all of this technology. But your point is that some of this technology might not find its way to Canada if it's a really painful route to market. If people like was Active Armor, was it the people who maybe tried and gave up, but having a centralized but distributed system will make the Canadian market more attractive, and Canadians will get best-in-class technology. So I guess that's one of the things that you're on the lookout for here as well. I know this is not an additive manufacturing thing, but it's certainly, there's a lot of metrology, there's a lot of robotics, there's a lot of AI going on. I think your point about maybe we don't need CAD technicians now to, I need something to do this. And, is that a combination of, it's a text prompt to AI, it's a scan, and, the previous speaker with, where we see this fusion of all of these technologies, it's very exciting. I'd like, if it's okay, does anybody in the audience have a question? Let me give you the microphone.
Thank you. I promise not a real hard one. At 28-1, with what you were saying, what's the argument that you're getting from hospitals not to do this? Like, why aren't they all signed up? Why is it just a few?
It's because it's new innovation and technology, and healthcare is, and understandably so, but it's probably one of the most risk-adverse sectors in the world. And the challenge becomes is that I think the executive groups see it, they understand it, they know this is where the world's going, they want to participate, but when they have nurses and doctors that are experiencing burnout, and where do you put your dollars, and where do you actually put the resources to be able to onboard some of this, it sometimes seems, I think the view is that, it's another IT project, or, we're out doing things when the real problem is over here. So, if nothing, we're persistent, I would say. And there's lots of other easier worlds to probably pursue. But we're really passionate about the fact that, you know, everyone, right? Like we've got aging parents, we've got children, ourselves. We all want better healthcare. We all deserve access to better healthcare. And we really strongly believe that this has the ability to move the needle significantly. But what's ultimately ended up happening, I guess, to answer your question here as well, is that we think we're hitting a bit of an escape velocity, is that every time we sign on a new client, and it's proven, because the healthcare always looks to who else is using it. So now that we're getting more and more of those clients onboarded, everyone is seeing it, 3D printing is in the news feeds all the time, and they know they have to be a part of it. And for us, a huge part of the solution development in our software was just, how do we very easily and effectively onboard a client that is already resource constricted and overburdened? And so those are some of the innovations we're actually building in our platform. It's just to make it really, really easy for them at the end of the day.
Thanks, Mark, and I'm going to leave you under the glare of the spotlight. Okay, another question from Frank.
Hi, I really love the idea. It's great. One of the challenges I see that could be happening is the ability, when you have those regional hubs and the different capabilities, how do you feel that you'd address the people who would actually work the 3D printer? It wouldn't be the healthcare workers, would they have to have special people, special training?
We see the future as a blended situation. There's lots of healthcare workers that love their 3D printers and don't want to give them up and have all the technical skills and talent to operate them properly. The challenge becomes, these healthcare workers are typically, again, it's one person or a couple of people inside a given department. So a part of the features and the functionality that we're opening up is the ability to allow others to request services if the machine is already inside healthcare, to do that in a standardized and auditable way for the healthcare organization, so people aren't running science experiments. And then that gets supported with larger regionalized distribution hubs. If you need one of something, maybe you make that inside the hospital, or if it's very specialized to a patient. But ultimately, if you need 1,000 of something, you can do that regionally and then distribute it more effectively. So, you know, a lot of the challenges, and you've identified them, you know, very accurately, is what are the software controls? What does the interface look like to be able to make sure that those machines are managed properly, that you're getting quality of output and consistency and all of those things. So it's not straightforward, but at the end of the day, we really do think it's a blended reality of some machines inside the hospitals and then the distributed kind of more regional network that backs that up for volume and other specialized capacity.
The project we did with Engine actually in 2023 was with Mosaic Manufacturing out of Toronto, and they have these really cool, we had a picture of it in there, they're called arrays, and it has 4 printers inside of it, and it's operated with an autonomous arm that takes the plate out and replaces a clean one. So yeah, like a nurse can come up on her to wherever it is, it's almost like a vending machine, pick up her order, and these things can run autonomously for like 72 hours, and we can manage it remotely as well. So I think that's the future. It's like a blend, as Mark said. If it's low volume, high value, it's in the hospital, and otherwise we can handle it.
Yeah, we use the concept of your inventory room is a digital closet, right? You press the button and it makes the thing that you actually want. I'm a Star Trekky fan, so like for me this is like getting very replicator-esque, where you can kind of talk to a computer and get what you want. But we're obviously not atomizing physical objects, but there's a lot of similarities kind of between that, and I think the supply closet of the future, at least a significant portion of it is digital.
I'm just going to jump in. I'll leave the microphone here, but it's following up on this question here. If it's such a great idea, why isn't everybody doing it? And our job is to give you tough questions. So it's a two-part question. One is, you can't 3D print every solution. So is your system open to all forms of manufacturing? That's part A of the question. And why stop at healthcare if this digital workflow can take so much cost out of procurement? Go for it.
So On the technical side, I would say absolutely yes. You know, during the pandemic, we actually utilized, we created a couple of additional initial projects to support, because of all, well, everyone knows what happened during the pandemic. You know, global supply chains essentially shut down. So we actually took a couple of those projects, designed them, got them up and running with 3D printing, proved out the prototype, and then moved them to an injection molded process. So at volume where it makes sense, 100%. Like, you know, there's currently we're probably mostly based in the additive market, but as we go forward, you know, our goal is just to move it into the, ideally locally or you know, within the regional market space, but to utilize whatever the best manufacturing method is for that type of technology. And so, you know, we're moving into different types of machines, you know, edging our way in, I would say, into the metal side of things as well, and then relying on other experts to kind of bring that together. The second part of your question, the first,
Why stop at healthcare?
yeah, so, you know, given where we're at right now, we need to be myopically focused, I think, to be successful. If we try to go do energy and aerospace and automotive and healthcare, I think we're going to spread ourselves too thin. So at the end of the day, you know, for any of you who've studied market theory, we penetrate the market into, we get very specialized into a vertical, but then once you've got that up and running and it's kind of on its own, we then can pick off the next market vertical. So, you know, we'll never say never for sure. I think this platform is transferable across other industries, especially ones that are fairly highly regulated. You know, if you just want a product for your garage, you go to Thingiverse or wherever, and you can grab and print those things. But ultimately, if it's got to go through a regulatory environment to get into the actual, you know, frontline usage, we think this platform will certainly be transferable in those markets. But so it's not never, it's just maybe not now.
Anyone else from the audience at this stage? No, if not, I think I'd just like to give a huge round of applause to Mark and Jacqueline. Thank you so much.
Thank you, Mark.
Thanks, Mark. It's a real pleasure.
Thank you.